this is an iHeart podcast. Guaranteed human.
With no fees or minimums on checking accounts, it's no wonder that Capital One Bank Guy is so passionate about banking with Capital One. If he were here, he wouldn't just tell you about no fees or minimums. He'd also tell you about how Capital One cafes are open 7 days a week to assist with your banking needs. Yep, even on weekends. It's pretty much all he talks about, in a good way. What's in your wallet? Terms apply. See CapitalOne.com/bankguy. Capital One N.A., member FDIC.
Hey folks, owning a home means one thing. Something's gonna break. AC, plumbing, fridge, and it's never convenient or cheap. That's where American Home Shield comes in. An AHS Home warranty can help protect your wallet from pricey breakdowns on even your oldest appliances and systems. And if they can't repair the covered item, they'll replace it. So check out American Home Shield and get 20% off any plan at ahs.com/SYSK and see promo details. See ahs.com/contracts for coverage details, including service fees, limitations, and exclusions. American Home Shield. Don't worry, be warranty.
Welcome to Stuff You Should Know from HowStuffWorks.com.
Hey, and welcome to the podcast. I'm Josh Clark, and there's the chipper, cheery Charles W. Chuck Bryant.
Howdy.
And there's Jerry over there. Say hi, Jerry. No, wait. How are you doing, man?
I'm well, sir. How are you?
I'm pretty well myself. I'm feeling all right, feeling a little fit.
Yeah?
Yeah. A little sweaty, as you can tell, but I'm all right.
It's gross.
It is. I don't smell, do I?
No.
Okay, good.
So, friends, listeners,
countrymen,
you're going to notice a little something different in this week's feed. Tomorrow, this bears a little explanation. We are dropping episodes 1 and 2 of my new movie interview show, Movie Crush. We're dropping those into the Stuff You Should Know feed. Something we've never done here at the network, but we're going to, I guess I'm the lab rat on this one.
The guinea pig.
The guinea pig?
Sure.
Yeah, I guess either one, right? The guinea pig doesn't die. The lab rat dies.
Yeah, I guess so. But let's go with the guinea pig for sure, then.
All right. Well, either way, we are dropping those into the Stuff You Should Know feed, and we wanted to alert you. So when you saw all these new things, you didn't rebel against us like everyone hated U2 when they delivered the world a free album.
Right. Yeah. I mean, this is not a U2 album. It's your new show. It's more important than any U2 album.
Oh, well.
You know?
I appreciate that.
Yeah.
So yeah, that's why they're there. And episode 1 is, the great Janet Varney with, we talk about the movie Tron. Nice. And, that's the nature of the show as I talk to people about their favorite movie. And episode 2 is, Tig Notaro.
Wow.
Talking about the movie Mask. And that one is a very special episode. And I'll tease it with this. We recorded that interview or conversation rather seconds after she got the call that she was cancer free at the 5-year mark.
Oh, wow.
So, she started crying at the beginning and I didn't know what was going on. I gave her some time. I was freaking out and it turned out to be good news, but, and I explained that all at the onset of the episode, but it turned out to be a very special experience.
Man, Chuck, you're like Barbara Walters.
I didn't get it out of her. It was just weird timing.
Yeah.
But, anyway, those are in there and, it won't happen every week. But I would love for you to subscribe.
Well, yeah, that's the way to get it, right?
Yeah. Just subscribe anywhere you listen to podcasts.
These are a couple of gifts, a little gems.
That's right. And, I appreciate your support on it.
Yeah. Well, way to go, man. Congratulations. I speak for me and the rest of the world when I say we are looking forward to this.
Thanks, dude. And, I'm going to have you on as a guest. It's going to be very strange and awesome.
Yeah, I think it'll be neat. I'll start crying too.
Do you know what your favorite movie is that you would pick?
I got a couple I think I could choose from. Sure.
All right. Well, hold on to that then.
Okay.
And we'll just pick that up later.
Okay. Well, congrats again, man.
Thanks, pal. Shall we warm the globe?
Yeah.
All right.
So, Chuck, I don't know if you've heard about this term recently, but it's been in the news lately. Global warming. Are you familiar?
It does ring a bell.
Okay. Well, just in case for those people who aren't aware of global warming, global warming is what we're talking about today. And a lot of people confuse it or use it interchangeably with climate change. And it turns out that's not actually fully accurate. Global warming is a symptom of climate change as a whole. And climate change is a whole bunch of differences to the Earth's climate. We'll get into what climate is in a second. And one of those is global warming. Also things like extreme weather events, increased drought, increased temperatures, sea level rises. All these things put together, that's climate change, right? Or the result of climate change. And global warming is one of them. So global warming is climate change, but not all climate change is global warming.
Right.
I just wanted to make sure we got that out of the way to begin with.
It's like the square rectangle thing, which I can still never keep straight.
Well, and I think the what?
Like every square is not a rectangle, but every rectangle is square, or the reverse of that, whichever it is.
I've never heard that before.
What?
I even aced geometry the second time I took it.
Well, it was clearly a class that didn't care about squares.
Yeah, I guess not. I mean, they always talked about rectangles, but squares were never brought up.
Yeah. I think it's, I'm not going to dig myself a hole there.
That's probably best.
So, global warming, if you want just a kind of a straight up definition, is, the science community defines it as this, and they should know.
Yeah.
It's a significant increase in the, climatic temperature over a relatively short period of time as a result of, activities of humans. And by increase in short, we're talking like 1 degree Celsius in a couple of 100 years is global warming.
Right, because the effects of climate are so pronounced on such a, like, with just small incremental changes.
Oh, yeah.
That is climate change. Something that if you just look at it on paper, you're like, that's nothing. Who cares about 1 degree? Actually, the point of global warming is that when you have this increase in global temperatures, a whole basket of events starts to take place. That's climate change. Like global warming is related to climate change, right? It can trigger other climate changes.
That's right. And, you hear a lot of people you hear a lot of numbskulls talking about weather as if it is climate.
Right.
Like, a very harsh winter might come and they'll say, yeah, global warming, right.
That's a great numbskull.
It's not the same thing. Weather is local. It's short term. Climate is long term. It's not even like the weather over a period of a year or even a couple of years. We're talking about generally predictable average weather conditions in a region over a long, long period of time. So you can safely say in Green Bay, Wisconsin, it is cold in the wintertime. That is the climate of Green Bay and that Midwestern region as a whole.
Right, but if it snows in February of, next year on a Tuesday, then that's just the weather.
Yeah, or if it snows in Miami once, then that's not a refutation of what climate change means. That is a weird anomaly, and those happen.
Yeah, and this is a Grabster and Strickland co-joint, by the way. So that's why
heavy.
It popped off the page, if you noticed. But one of the things they wisely point out is what you just said, that yeah, some weather anomaly happens like that. Even if it happened 3 years in a row, I think a lot of scientists would pay attention to why it snowed in Miami 3 years in a row.
Right.
But if it went back to normal or something like that would not necessarily be climate change. That's just a weird occurrence, right? Yes. Climate change is this change in predictable changes.
Yeah, and that can take like thousands and 10,000s of years sometimes.
Right.
Often,
normally,
most times.
Under natural circumstances. And here is where we come to the current use for global warming, right? Global warming can happen by itself naturally. The Earth basically, in its current present state, swings back and forth between glacial periods and interglacial periods. So cool periods and warm periods. And for an ice age to occur, the global temperature only needs to drop by about 5 degrees Celsius on average. And all of a sudden we're in an ice age, right?
Yeah, that doesn't mean the entire Earth is a big round cube. Round cube. Wow.
That's like a square rectangle, but not at all the same.
Well, when you go to a fancy cocktail bar and they have those awesome round I want to say ice cubes again, ice spheres.
Yep.
That's not what the Earth looks like necessarily during an ice age.
No. It's just much cooler. And like, because it's cooler by say 5 degrees Celsius, like a lot of stuff changes. It's the same thing as global warming, but on the opposite end, right?
Correct.
Like you have changes in migration patterns. You have changes in habitat for animals. Some things go extinct during the transition. Sea levels change. A lot of stuff happens, right? So this is part of the normal process of the Earth. But the Earth's kind of got it like, hey, I've got this under control. I don't need any help from you humans.
Sure.
And when I do this is the Earth talking in first person. When I do change from a glacial period to a warm period, it takes many tens and tens of thousands of years, right?
Yeah.
You humans here, again, this is still me, the Earth.
Uh-huh.
You humans are really messing with my program here and accelerating the process. And you know what? I'll even give you a clue as to what you're doing that's making it so bad. Carbon dioxide emissions. Bam, said the Earth, and dropped its microphone and walked away.
Yeah, and then it went back and picked up his mic and said, and maybe stop littering.
Yeah, that's another
And then
one.
it dropped the mic again.
Yep.
We should talk a minute about a wonderful group called the IPCC, the Intergovernmental Panel on Climate Change.
Yes.
A lot of very smart people there.
Oh man. Can I just say, it's, to me, the IPCC is one of the coolest things humanity's ever come up with.
Yeah.
Cause it's the world coming together saying, we got a real problem on our hands. Let's get our smartest people together and create a database here of good science.
Yeah. And those people are specifically about 2,500, actually more, 2,500 scientists from around the world meeting together in places like Paris, because why not, right?
Sure.
They did this about 10 years ago and came up with a lot of, sort of a lot of distressing observations. We'll just tick through a few of these. As far as temperature goes, and, like we said, 1 degree Celsius can make a big swing in what kind of changes we see on the planet. Between 1901 and 2000, the Earth warmed 0.6 degrees. So that's, if you adjust that to 1906 to 2006, it climbs up to 0.74 degrees. So about 3/4 of a degree in temperature rise during that 100-year period.
Right. And
that's a lot.
It is a lot. And so a lot of people say, well, you guys just said the Earth tends to do this on its own. Maybe that's it. Well, actually, no, there's a lot of science that the IPCC has been able to come up with that shows pretty clearly that this is human-caused stuff that's actually creating this increase in temperature. And again, it seems to come back to carbon dioxide.
Yeah. Should we tick over a few of these other observations?
Yeah, for sure.
Let me see. Here's a good one. The ocean's temperature has increased to at least depths of almost 10,000 feet down. The ocean's temperature has increased.
Yep. Not a good thing, because that's how, what glaciers tend to melt, is from underneath.
That's right.
What else, Chuck?
Westerly winds have been growing stronger.
Yep.
Droughts have become more intense, have lasted longer, covered bigger swaths of land. What else here? Precipitation has increased in the eastern Americas, northern Europe, parts of Asia.
But it's decreased elsewhere.
Yeah, and we'll get into this a little bit. A little bit of global warming can mean longer growing and better growing seasons in some parts of the world, but devastating to other parts of the world.
Exactly.
I guess I let the cat out of the bag there, but we'll go over that again later. And how about this one? The warming trend of the last 50 years is about double of the last 100 years. So what that means is the rate is increasing. The rate of warming is increasing.
Yeah, actually, so I think the IPCC has determined that each of the past 40 years has been warmer than the average temperature of the 20th century, and that 2016 was the hottest year on record, and the 12 warmest years on record have occurred since 1998. Dude, you should see we'll get into it. Some of the charts that you can find. And again, if you're even remotely interested in this, just go look up the IPCC's stuff.
Yeah.
And some of it, you have to be a climatologist to understand what in the name of God they're talking about. But other stuff, especially if you read like executive summaries of studies and reports and stuff.
Yeah.
Like that's meant for like a non-scientist, specifically often like policymakers, to read and understand, right? So the average person can understand that. And they have some really great stuff that's showing like all of the changes that the world is going through thanks to these increases in the global temperature. And again, some of the charts that they have are just stunning when you see them.
Yeah.
Cause it's like going along fine, everything's fine. And then, oh my God, what the hell just happened?
Yeah.
Basically.
And it was the Industrial Revolution.
It was, but also one of the things that they found recently, especially in the last like 3-4 years, I believe, is that I think you were saying, the increase in global temperatures, but also again the increase in carbon dioxide has really shot up over the last like 50 years. Like from the beginning of the Industrial Revolution, I think they usually start that about 1750 to maybe 1800 at the latest, up to like 1950 or so, 1960. Like, yeah, there's a pretty surprising increase, but it has just skyrocketed in the last like 50 or 60 years. So, they're seeing like the science is bearing out the kind of the general theory of global warming, which we should probably talk about this theory of global warming, right? Because like we said, it's not just, a human cause mechanism. Like basically it's an already existing natural mechanism that basically keeps the earth nice and toasty for, life and water.
It keeps us from being Mars.
But we have started messing with it big time because of our contributions to this normal cycle.
Yeah. So should we talk about the greenhouse effect a little bit?
Yeah.
The greenhouse effect is literally what keeps us from being Mars. It is a good thing when it occurs naturally because, like you said, it keeps us on, it makes Earth habitable and lovely and nice for the most part.
Yes.
So Strickland and the Grabster, I'm not sure who came up with the car analogy, but it's a pretty good one.
I agree.
If you go into your car on a hot summer day and you get in your car, it's been sitting out in the sun for a little while, it's a lot hotter than it is outside. It's kind of a no-brainer, but you might not have thought about why that happens. It's not magic. What's happening is the sun that's coming in through your car windows gets absorbed by the interior of your car, whether it's your seats or the dashboard or basically kind of everything in the car, absorbs that heat, and that heat is then eventually emitted back out and radiated out from the seats and things like that.
Right.
But it's at a different wavelength than that initial sunlight that came in. So some of it might get back out of the window, but most of it stays kind of trapped in that car. So the end result, the net, as they would say in a corporate meeting, is that there's less energy going out than coming in.
Right.
So your car's going to get hotter.
So pretend your car is the planet Earth, basically.
Which would be great.
And the windshield is the atmosphere, right?
Yeah.
So, that's the greenhouse effect in a nutshell. As it relates to the actual Earth, about 70% of the solar energy that is directed toward Earth, right, stays on the planet, right? And instead of it being absorbed by car seats and floor mats and stuff like that, it gets absorbed by the ocean or land or plants or you, right?
Right.
And so about 30% of that stuff that didn't make it through, it was reflected back by clouds, particles in the atmosphere, a bunch of other stuff, right? But as you're sitting there getting warmed by the sun, you actually have the potential to re-emit that heat. And so that stuff starts to go back through the atmosphere out of space. Some of that stuff makes it out into space, but there are other particles that take that solar energy, usually in the form of heat, and absorb it. And when they absorb it, they re-emit heat, and then they direct it back down at Earth. And the process continues. And in some cases, some of the stuff that they re-emit, they end up reabsorbing themselves. So that there is more heat that's being trapped and sustained on Earth than is being allowed to escape back into space at any given time.
Yeah, just like your car.
Right. And again, this is like a positive feedback cycle that creates the atmosphere. It also sustains the atmosphere. It also keeps water here on Earth, because water tends to heat up and rise, but then it will cool off in the atmosphere and fall back down as precipitation. And as long as it can fall back down in the atmosphere and nucleate around some of these particles that are trapped in the atmosphere, we've got water here on Earth.
That's right.
So it's all thanks to the wonderful, glorious greenhouse effect.
Yeah, so that feels like a good place to pause. Let people, let that soak in a minute, like a hot sun on a black car seat.
Like a warm chutney on your forehead.
Oh my God. And we'll be back a little bit to talk about these gases in the atmosphere that we're talking about here. So you're considering getting a home security system, but you want something that fits your space. Well, with ADT Blue, it's easy to customize a system that's right for you and set it up yourself. Just pick the kit and monitoring system that makes sense for your home.
Yeah, well, let's say you're worried about package theft right off your front porch. The ADT Plus app can walk you through setting up a new doorbell camera kit. Once it's installed, ADT Pros can help you keep tabs on it 24/7, or you can manage it yourself from the ADT Plus app.
That's right. There are no long-term contracts, so you can change your monitoring plan whenever you want. The flexibility doesn't end there either. You can add to your system as you need with things like extra cameras or motion sensors.
Some life decisions are hard, but thanks to ADT Blue, you can get DIY trusted ADT home security in a snap. Head to ADT.com/BLU to build your system today. And to find out more about home protection, check out a new episode of Grown Up Stuff with security expert Joe Mazza out on June 9th.
Work can be a little weird. One minute you're in a meeting that could have been an email. The next you're trying to decode corporate jargon that somehow means nothing. And don't even get us started on the quick sync that turns into a 45-minute deep dive.
Yeah, well, the truth is figuring out your career isn't always straightforward. Whether you're trying to grow, pivot, or just stay relevant, it can feel like you're navigating it all on your own. Well, that's where LinkedIn comes in.
That's right. LinkedIn can help you grow your career, helping you confidently navigate your path with insights, ideas, and inspiration from your professional community. You can stay up to date with the latest trends in your field, connect with people who get it, and discover opportunities tailored to your goals, your experience, and what actually matters to you.
Whether you're looking for something new or just trying to grow where you are, LinkedIn gives you the tools and connections to move forward with confidence. Because LinkedIn is the network that works for you. Visit linkedin.com/knowstuff to learn more.
All right, so we're back. I think everyone probably understands the greenhouse effect. If you remember your hot car.
Yeah.
It's kind of a nice, easy way to think about it.
Sure.
So when you were explaining the more, like the Earth's version of that, with getting absorbed, hitting things in the atmosphere, we're talking largely about three things. Carbon dioxide, methane gas, actually four things, nitrous oxide, and water vapor.
And there are a lot of others, but as far
Sure.
as like stuff that really has the biggest impact on global warming, it's these guys.
Yeah, so we'll start with CO2 because that's the one you hear about most often. Carbon emissions gets all the glory in the headlines these days. CO2 is colorless. It's gas. It is a byproduct of the combustion of organic stuff, and it makes up a very small part of the Earth's atmosphere, 0.04%. And most of it that's up there has been there for a long, long time. It's from volcanic activity. However, we are pumping lots and lots of CO2, additional CO2. And remember, there's a delicate balance going on up there as it is.
Right.
So, like you said, Mother Earth doesn't need us adding to this. And we have been adding CO2 like it's gangbusters.
Yeah. So like that you remember when I was talking about how water turns into vapor and rises and then falls back down? That's the rain cycle. There's also a carbon cycle where carbon molecules just kind of go back and forth between the atmosphere and the earth. And apparently every year, 230 gigatons of carbon are released into the atmosphere from the earth, from plants, from rocks, from us. And then about the same amount, another 230 gigatons comes back down and is locked into Earth from the atmosphere, right? And it's, like you said, Chuck, like a pretty nice balance. The Earth has got this. Please don't mess with it. But when we take carbon and unlock it from these carbon sinks, like, we bust up rocks in mining operations. We burn fossil fuels that have carbon locked into them. We cut down trees and burn those things as fuel. That releases more carbon, and it messes up that delicate, pretty much even exchange between the atmosphere and the earth.
Yeah, and that's a big problem because carbon has a knack for absorbing infrared radiation. So that energy that escapes the atmosphere, that's the form that it comes in. Mm-hmm. So all this extra CO2 means basically, like your car, just an overall increase in temperature.
Right. And so not only does it absorb infrared heat and hang on to it, there's a lot of it. We just finally, in the first time in the history of the human race, all of humanity, not since the Industrial Revolution, but ever since humans have been around, the Earth reached 400 parts per million, meaning that out of every million molecules that you just snatch out of the air and count, you're going to come up with 400 of those as carbon atoms, right?
Yeah.
Or carbon dioxide molecules. So that's new. That's a big deal. And the problem with that is not just that there's a lot of carbon dioxide in the air, but it's like you said, the more carbon dioxide there is, the more radiative heat that comes back down to Earth that doesn't escape into space, and the higher the global temperature gets.
Yeah, and just to put it into perspective, 400 parts per million now, and that's 2017 numbers, I guess.
I think in 2015 we hit 400, and we're up to like 404 now.
So that pre-industrial revolution was about 280 parts per million. So it has swelled by about 124 parts per million since the Industrial Revolution, which is pretty staggering.
Yeah, and there's apparently a way that you can tell when you're actually measuring the carbon dioxide molecules themselves where they came from. And ones that are introduced into the atmosphere from burning fossil fuels have a specific signature that we can detect. And we have seen that as the global temperature has increased and more carbon dioxide has been introduced into the atmosphere since the Industrial Revolution, so too has the concentration of that specific type of carbon dioxide. So there's a strong correlation between the fossil fuel burn carbon dioxide that we humans have put in the air with rising global temperatures.
All right. Moving on to nitrous oxide, N2O, which we did a whole podcast on this, right?
Yeah.
That was a good one.
It was a great one.
Mainly because of that tank that we had here in the studio.
I know, like we're method podcasters. That definitely enhanced the whole thing.
So, N2O is another greenhouse gas, super important. And we are not releasing, like human activity is not releasing nearly as much as, we are CO2, but, N2O absorbs a lot more energy, like 270 times as much as CO2. So that makes it, something we really need to pay attention to, and we are paying attention to it. It just doesn't get all the headlines.
No, it definitely doesn't. Just because there's so much less of it, right? And, whereas it takes like tens of thousands of years for, the 20% of any given carbon dioxide emission to leave the atmosphere, it takes about 114 years for a full emission of nitrous oxide to leave the atmosphere.
Yeah, as far as man-made, it is also a byproduct of combustion, and a lot of fertilizer, nitrogen fertilizer that they use on crops is releases the N2O into the atmosphere as well.
See, to me, all you have to do is like seed the atmosphere with a bunch of hippies and let them huff all the nitrous oxide right out of it. Problem solved.
That's right.
Because you've also gotten rid of
Great Fish Concert in the Sky.
Exactly.
What else do we have? Methane?
Methane's a big one. And this is super overlooked, but I remember hearing about this when people first started realizing like, oh, that's a really big problem. There's very little amount of it, whereas like there's 404 parts per million of carbon dioxide in the atmosphere these days. We can measure about 1.7 parts per million of methane.
Yeah.
But it absorbs and emits thermal energy like gangbusters as well, far more than CO2. I think about 20 times more. And there's a lot of different places where it comes from. Like when we mine coal, it releases methane.
Yeah.
When our ample herds of livestock fart,
Yep.
they release methane. No joke. That's
Yeah.
actually a huge contributor of greenhouse gases.
Oh yeah, we talked about that I feel like years ago in another episode.
Surely we have.
Yeah.
Another one, Chuck, do you remember our plasma waste incineration episode?
Sure.
Well, remember one of the things we talked about was that the average landfill gives off methane. And that's a huge problem too.
Yeah.
So like if you go to a landfill and you see that there's flames around it, they're actually burning that stuff off because the CO2 it releases after it's burned is actually preferable in that case to the methane just being allowed to escape.
And
that's bad news.
It is bad news. And there are scientists who have even posited that maybe like, tens and hundreds of thousands of years ago, that large scale venting of methane into the atmosphere, like if a big, block of ice cracked open and unlocked a big methane, bubble from under the ocean, that could have caused like maybe a mass extinction.
Right.
Like, cause it was released so quickly into the atmosphere.
Yeah. Like we're doing now, basically.
Yeah. On a slower basis. I don't think anyone's saying that's going to happen.
No. I don't know. I think like that is a concern that as Arctic ice melts, that methane bubbles could be released, which would just be a nightmare on top of a catastrophe.
That's right.
There's another problem with methane too, that in the atmosphere, it frequently converts to CO2. So it just not only contributes itself, it also contributes to the CO2 emission problem.
Man.
There's also, Chuck, another thing called short-lived climate pollutants, SLCPs. They don't get a lot of press either, but a lot of people think that if we focused on these, we could really see some real results in the short term. Supposedly, SLCPs account for something like 30 to 40% of global warming, but they are particles like black carbon. Methane counts as one of them. Hydrochlorofluorocarbons.
Nice.
And they can live in the atmosphere from, say, like days to tens of years, and then they go away. And if we really cut down on some of those emissions, we would see the effects of that very quickly.
Wow.
Yeah.
So speaking of effects, I guess we should kind of talk about what this all could mean and does mean.
Yep.
And is meaning.
Sure.
Number one, we can talk a little bit about sea level. Or sea levels. Glaciers and ice shelves are melting all around the world. And losing large chunks of ice like this can accelerate this warming because there's less of the sun's energy. We talked earlier about it being reflected by ice sheets and things like that.
Right.
These reflective surfaces. Less reflective surface means less is getting reflected away. So just at like the very base level, that's going to be an increase in temperature.
Yes. Also, depending on where the glacier is, it could contribute to sea level increases too, as we'll talk about.
Yeah. I mean, we might as well hit that, huh?
Okay. So if, one of the things that I learned from this that I just absolutely did not know, but makes total sense, is that the Arctic sea ice, if it melts, it will contribute 0 to a sea level increase.
Yeah, interesting.
I had no idea, but it makes total sense because it turns out that Arctic sea ice in particular floats on the sea.
Yeah.
So it's already in the sea and it's already contributed to the sea level rise. If anything, if that stuff, if we went through an ice age and all that stuff froze into basically a frozen landmass, then you'd see a sea level decrease. But the way it is right now, there wouldn't be a sea level rise if it melts completely. There are other places around Earth where the glaciers and ice caps are basically land masses, and if they did melt, then you would see a sea level rise just from that melted water, right?
Yeah, I mean, we're talking about Antarctica there, and the likelihood of Antarctica thawing out is not great, which is good.
Well, not all of it, but there's certainly parts of it could.
Yeah, for sure.
And then same with Greenland, too.
Well, yeah, Greenland's a problem because it is much closer to the equator, so temperatures are higher there anyway. It's not like negative 37 degrees on average like it is in Antarctica.
Right.
So I feel like I have to say that so specifically.
Antarctica. The Arctica, yeah. And the other problem too with this loss of ice, like people might say like, no, it's crazy. Like I see plenty of glaciers there still. But if every season a little more melts off than is replenished by snowfall in the winter, you have a net loss of ice. And then over time, if you look at it on a scale of a decade or 2 decades or 3 decades, that's a substantial amount of lost ice. And that is what increases the sea level. That leads to sea level rise.
Yeah. So as far as the IPCC is concerned, they estimate that sea levels rose about a little over 6.5 inches in the 20th century. Doesn't sound like much, but it is a lot. Like sea level rise in low-lying coastal areas can mean pretty bad flooding at just mere inches.
Right.
They propose that if things continue to go this way, they could rise by as much as 22 inches, almost 2 feet by the year of 2100. And brother, if that happens, we're going to have to redraw the world map.
That's true. I was looking, I was like, how high is Miami Beach? Miami Beach is apparently just under 4 feet above sea level.
Yeah.
New Orleans is, like 0 feet. I think it's maybe at 2 feet, basically.
Yeah.
There's a lot of coastal cities. Singapore, I think, Copenhagen, they're all like very close to sea level or just slightly above sea level. And so, yeah, 2 feet rise. I know the Maldives is frequently mentioned as like being under real threat from sea level rise. But even if you don't necessarily live in a coastal area that's 2 feet, just 2 feet above sea level, consider this. If the sea level rose just 6 inches, like they were saying, that means that when you have extreme weather events, which go hand in hand with global warming and are part of climate change, where it rains really hard and there's more major flooding than before, then it's already working with an extra 6 inches than any flood that you've been used to before.
Right.
So the floods are much more extensive. And that's a really good example of how interconnected the global climate system is, where if one thing gets messed up a little bit, it has all these other widespread effects around the world and on regions too.
Yeah, because I think they found that there are not necessarily more frequent like tropical storms and hurricanes and things, but they are becoming much more intense, and that's the issue at hand.
Yeah, and that one in particular has to do with the surface temperature of the oceans increasing as the temperature of the world increases, because that's where those storms, hurricanes and cyclones, get their energy from, is from the warm surface of the sea.
Yeah.
So if it's warm, that's like, you'll see them like hit land and like lose steam. And then when they go back over the ocean, they'll start to like regather their strength. That's because they're over warm water again. And that's where they get it all from.
Yeah. Plus there's, I don't think we mentioned this yet about the density of water.
No, and I don't want to go anywhere near it. You take this one.
Well, very simply, water is most dense at 4 degrees Celsius. So that's its kind of a homeostasis of where it needs to be. Anything above or below that temperature and the density is going to decrease. So the overall temperature of the water is going to increase naturally. And this is not like human cause. But that will also cause the oceans to rise some. And that's just a natural thing.
Right. Well said.
All right. I'll just leave that with, park it right there.
I'm glad you mentioned that though, because you don't see that really ever. Like no one ever mentions like, oh yeah, water's just going to expand as it warms.
Yeah.
I've never thought about that one either.
Or cools, I think, right?
Yeah, or cools.
Yeah.
It's a weird thing. Weird material. So, let's take another break and we'll get back to explaining why global warming's a real pain.
Hey, everybody, here's a fact for you. In the United States, there is a break-in every 26 seconds, and that means that somewhere right now, an intruder is getting closer. And the problem with most security systems is that they only alert you after the break-in has started, and that's too late.
Well, that's what makes SimpliSafe different. They use alerts. SimpliSafe's U.S.-based live agents, they identify threats on your property and help deter them before they actually break in. So the intruder never gets into your house. The crime is stopped before it even starts.
That's right. And another great thing about SimpliSafe is they have no long-term contracts. They give you peace of mind and great value with their monitoring deterrence plans because they just start at about $1 a day.
Yeah, SimpliSafe sent us a setup years back, and I still use mine every day.
Yeah, and apparently setup, you can do it by yourself in under 30 minutes, so it's a really good value and it doesn't take long.
So if you want to experience the SimpliSafe peace of mind, you can take advantage of the SimpliSafe discount offered to Stuff You Should Know listeners. Right now, you can get 50% off your new system by visiting simplisafe.com/stuff. That's half off at simplisafe.com/stuff. There's no safe like SimpliSafe.
Work can be a little weird. One minute you're in a meeting that could have been an email. The next you're trying to decode corporate jargon that somehow means nothing. And don't even get us started on the quick sync that turns into a 45-minute deep dive.
Yeah, well, the truth is figuring out your career isn't always straightforward. Whether you're trying to grow, pivot, or just stay relevant, it can feel like you're navigating it all on your own. Well, that's where LinkedIn comes in.
That's right. LinkedIn can help you grow your career, helping you confidently navigate your path with insights, ideas, and inspiration from your professional community. You can stay up to date with the latest trends in your field, connect with people who get it, and discover opportunities tailored to your goals, your experience, and what actually matters to you.
Whether you're looking for something new or just trying to grow where you are, LinkedIn gives you the tools and connections to move forward with confidence. Because LinkedIn is the network that works for you. Visit linkedin.com/knowstuff to learn more. All right, Chuck, so we talked about the ice caps melting, we talked about glaciers melting, we talked about sea level rise.
Correct.
There's also, people are out there saying like, that's great, but how does it impact me?
Yeah.
A human. That's what I want to know about. Well, there's tons of ways because as technologically clever as we humans are, we are extraordinarily dependent on the Earth. So as this climate change happens due to global warming, we're going to see all sorts of problems. And we already are starting to see problems.
Yeah, so we did mention earlier that if you live in a temperate area, if you got like 4 kind of lovely seasons, like let's say Atlanta, Georgia, for instance, you may have a longer growing season. You might have a bit more rain. It might be actually good for the crops here in Georgia in some ways, but other parts of the world, less temperate zones are going to see big temperature increases, way less rain, and longer droughts, worse droughts, bigger deserts. It's not going to be so good for those places.
No, they apparently have found that every trillion tons of CO2 it contributed to the atmosphere raises the global temperature average by about 3/4 of a degree Celsius.
Wow.
And then they went and correlated that each 1 degree Celsius increase in temperature equals an evaporative increase of about 7 to 15% here on planet Earth in the soil, right? So as temperatures increase, there's going to be less water in the soil, which affects crops and leads to things like droughts and even desertification as well. And man, every time I throw out one of these terms, I'm like, we did an episode on that. We did an episode on that. And droughts.
We've been dancing around this one for a while.
We have. I'm glad we finally tackled it, man.
Agreed.
You're doing great, by the way. Well, hold on. So as the water evaporates from the soil and goes up and is locked into the atmosphere, it's eventually going to come down. And when it does, you're going to have far more severe flooding and precipitation than you would have normally when it was just going up and coming down and going up and coming down like on its normal cycle.
Yeah.
So that's one way that it can affect you, because while it's turning to droughts, you got wildfires. And then when the soil gets degraded and there's suddenly a lot of rain, you've got flooding. and people get carried away in their cars because they think they can drive across a flowing river.
That's not funny at all, by the way.
I guess not.
Just the way you put it was. Yeah. So one of the other devastating effects, and this one is kind of tougher to predict because haven't really seen what can happen with our living human eyeballs, but ecosystems. And I think did we do on ecosystems as a whole, or just have we talked about it forever and everything?
I think it's just popped up in so many of them. It seems like that.
Yeah, we've definitely covered coral reefs and things like that. We're talking about living ecosystems, and we all know they're very delicate, and the delicate balance of the ecosystem is what makes it worse. And we've talked ad nauseum over the past 9 years about how little things can happen in an ecosystem that will create this chain reaction. Mm-hmm. It's all interconnected, and we don't know what might happen in terms of global warming in our living ecosystem. Sure, some animals might adapt, some might move, but there would also be, massive amounts of extinction.
Right.
Coral reefs are already dying. We're seeing that with our eyeballs. Yep. Forests are dying off and turning to grassland. And it's not just like, oh, well, there they go. Now we have grassland instead of a forest.
Let's make some hula skirts.
Yeah. Again, it's that domino effect that we're going to see. It's just no one knows what it's going to mean in the end. It's really troubling.
Yeah. And I was like, well, how are ecosystems interconnected? I know they are, but how? So I looked up a good example and found salmon. So salmon are born in like little streams, and they end up like traveling down into bigger streams and eventually rivers and then estuaries, and then they actually go and mature out in the ocean, which I hadn't really thought of. And then when it's time for them to go breed, they swim back upstream, back into the rivers, back into the streams themselves. Actually, they go back to where they were born to breed and then die. And as they're doing it, they're basically acting as nutrient transport systems between all these different ecosystems each step of the way.
Yeah, it's like a seed being scattered in the wind.
Yeah, very much so, but a seed that can actually come back home and bring all the nutrients that it gathered like out in the ocean back into its home ecosystem where it was born.
Yeah.
So it's pretty interesting. And I mean, like, that's just a great example. That's just salmon, So yeah, the ecosystems are very much connected. So if something happens with one, it's going to have an effect on all the other ones. And like you said, some things will survive, some things won't. But the thing that I think most of us here on Earth are agree about is we should probably do something to stop those extinctions as best we can, even if we'll probably survive,
Yeah. And, this is a very USA-centric show for the most part, because that's where we're based. We try to think outside that box as much as we can. And in the case of global warming, it is the poorest nations of the world are the ones that are going to be hit the hardest. They're the ones a lot of times in the less temperate zones that are going to be hit with more devastating crop loss. But crop loss is going to be a big deal all over the world. It already is. There's something called the Carnegie Institution that estimates about $5 billion in crop losses per year due to global warming is already going on right now. And farmers are seeing a decrease of about 40 million metric tons of wheat, barley, corn, other cereal grains every year. So just 1 degree Fahrenheit, an average temperature of an increase could result in 3 to 5% drop in crop yields.
Right.
So it's a global issue. Sure, some of the poorest nations might be affected earliest and the worst, but it is going to touch every nation.
It definitely will, and it doesn't necessarily have to just be the poorest nations. It can be the poorest people of rich nations.
Well, yeah, true.
And it can be people who are very rich who end up living in areas that are hit, like Houston saw a lot of increase in waterborne illnesses because of the flooding from Hurricane Harvey. That's something that they otherwise wouldn't have had to have dealt with.
Yeah.
There's like that whole crop loss thing and starvation that it leads to. Like, there's a lot of ways people can be affected. And just like salmon, like we're connected to other people as well, even if they're on the other side of the world and, we're not really talking to them or don't really know them personally, we're still connected to them. So if they suffer a crop loss, it'll affect us all. And if they die of starvation, it ends up affecting us all.
Yeah, this I really like this computer model thing. Did you see that?
Yes.
That was pretty cut and dried, you know?
Yes.
So the IPCC, they used a computer model, and what they did was they tried to simulate climate change, and what they found was the only models that looked like today's climate that equaled, hey, well, this looks like what's going on today, were models that included the human contribution to global warming.
Right.
When they did not plug in the human contribution, the answer that it spit out was, no, that climate doesn't look like what's going on right now.
Right.
So that is basically proof that humans are contributing to this.
Right.
Straight
exactly.
up.
Yep. That combined with, the signature of the carbon dioxide from fossil fuel burning, all that jazz. Yes. And we should probably get to this part. Like there's a tendency among naysayers to be like, there's not even like scientific consensus. They're not 100% certain that it's us creating this global warming, right? And so science has really kind of taken it upon itself in the last decade or so to address this and say, yes, that's true. There's basically no such thing as settled science, but there is been so much, we've made it our business to create and conduct so much research and study all of this so closely over the last 10, 15, 20 years that we have basically come up with a scientific consensus that basically if you take any scientist on the street, there is pretty close to 100% chance that person is going to say, yes, climate change is real. Yes, global warming is happening. And yes, humans are causing it. Right?
Yeah, because they use words differently than we use words. And you sent this great article, Certainty versus Uncertainty, understanding scientific terms about climate change.
It's smart when there's a colon in the middle.
And for the average Joe or Jane walking around on the street, if you say the word uncertain, that means, well, you just don't know.
Right.
Scientists, when they use the word uncertain, they mean how well you might know something or not.
Right.
So that's a big difference. It sounds like word games, but very rarely is there absolute certainty in science. So their job is to research and limit that uncertainty as much as possible.
No, and that uncertainty and their public broadcasting of that uncertainty has been used against them. It's been hijacked and used against them to fight doing anything about climate change, right? So they have started to use, especially, if you go through the IPCC's, policymaker executive summaries, everything that they're stating, they will put how confident they are that
right.
what they're saying is true.
They have a structure to that now.
Right. And so most of the stuff that they're releasing as in their reports has something like a 90% chance or greater of being correct. So they call them a very likely outcome or a very high confidence. And I've even seen something called an extremely high confidence, which indicates 95% or greater. And then the come on, which is 99% or greater.
Yeah, so there are 5 points which they have, quote, very high confidence, end quote, about, or even greater. So at least 90% or greater certainty that the following.
Right.
Human-induced warming influences physical and biological systems everywhere. Sea levels are rising. Glaciers and permafrost are shrinking. Oceans are becoming more acidic, and ranges of plants and animals are shifting. So that's between 90 and 100% certainty on those things.
Yeah, they also say they're comfortable saying with certainty that the burning of fossil fuels and the clearing of forests release carbon dioxide into the atmosphere. They say there's no uncertainty about that. They also say that they've learned that carbon dioxide and other greenhouse gases in the atmosphere trap heat through the greenhouse effect. They say, again, there is no uncertainty about this. And that the Earth is warming because these gases are being released faster than they can be absorbed by natural processes. And then they say it's very likely, greater than 90% probability, that human activities are the main reason for the world's temperature increase in the past 50 years in particular. And so they're saying, like, we are scientists, we're the ones who are studying this. No, we're not, we can't say with unequivocal certainty that this is the case. But what more do you need? Like, we have studied this so closely.
Yeah.
We are so close to 100% certainty that like, what's the problem here? Let's just get on board. And there was actually a study, done in 2007 by this economist. It made the news cycle. His name was Dr. Peter Sagaris. And he basically said, if you look at the cost of doing something and the cost of doing nothing, statistically speaking, it makes way more sense to take steps to mitigate climate change and be wrong about the fact that it was us humans.
Yeah.
Than it would to take no steps at all, and be wrong about it. Actually, no, it actually was us humans.
Yeah. I mean, that's where I don't want to get too much on a soapbox, but I get angry that there are people out there that say, well, there's that 10% or less chance. Mm-hmm. So let's just gamble humanity, the future of humankind, on that 10% or less chance, because we don't want to get with the program and get behind green initiatives. Right. Because there's a chance. You're not 100% certain. I don't, that short-sightedness is staggering to me.
Well, plus also that it's been proven, I've mentioned that book before, The Merchants of Doubt, that think tanks have been set up to basically influence public thought and point out, like, scientists aren't 100% certain. And they're not looking out for you or the earth or your family. They're looking out for their business interests, because it's the fossil fuel industry. They're the ones who benefit the most from not taking steps against climate change. But even if you look at, some of these fossil fuel industry companies, they're like, no, we should probably do something. We can figure this out. Yeah. Even some of them are saying this now, as of 2014.
Amazing.
So, Chuck, speaking of 2014, there was, something big that happened, the Paris Accords.
Yes.
And in 2014, I think 195 countries came together and said, you know what? We're going to do something. We're going to do everything we can to keep the global average temperature from increasing 2 degrees above normal. 2 degrees Celsius, I should say, because that was kind of a largely agreed upon tipping point, that there would be a lot more extreme weather, sea level rise. We would feel the effects of climate change from a 2 degrees Celsius increase in global temperature. And so they took this really interesting approach where they said, instead of us coming up with a multi-government group that decrees stuff, we're going to just decentralize the whole thing. And how about every country come up with what their country can do on their own to fight global warming. And then we'll bring them all together and everybody will take a pledge and we'll go do it. And it was hugely successful. Like, out of 195 countries, 168 have ratified it. And the U.S. had a pretty good plan as well. I think we were going to pledge that we would reduce our climate emissions something like 26 to 28% by 2025, which would be a huge, significant contribution to fighting global warming. But we got pulled out of that one, I think in 2017.
That's correct.
So now the rest of the world seems to be carrying on without us, fighting climate change through their own decentralized plans. But that's where the United States stands right now. We have said we're not going to be taking part in that.
That's right, but that's not to say that the citizens of the United States can't do everything they can on their own, in their own lives, by doing some of the following things. First and foremost, decreasing our carbon footprint. And I'm going to put out a call for us right now to go ahead and do one soonish on carbon offsets, because we're a few years down the road from when carbon offsets first became a thing, and it's much more understood now.
Didn't we do one on those?
I don't think so.
We did. We've done them on some.
Did we?
Oh, I know what it was. We talked about that kind of cap and trade scheme in the acid rain episode.
Right.
Yeah.
Yeah, we should do one on carbon offsets though, because they're much better understood now, and then it's pretty clear now, like, the best ways to go about doing something like that.
Cool.
So we're not going to cover it too much here, but You can buy carbon offsets. Look for future podcasts. But reducing your carbon footprint is the biggest thing. I mean, it's really simple. The stuff that generates the greenhouse gases, if we create less of it, that's a good thing. Mm-hmm. So you doing that on a local level can make a big impact if a lot of people are doing that. Using less energy obviously is just a sort of a no-brainer. And this is just period in life, like just being less wasteful.
Yeah.
Whether it's water or, your lights that you're turning on or, riding your bike instead of driving your car. Like all of that makes a big difference.
And with electricity in particular, one thing we always mention is that even though it seems like your light bulb is fine, it's getting its power most likely from burning coal. So
is that electric car that you bought.
That's plug-in for sure.
Yeah, and your electric car is only as good as the energy where it gets its energy from.
Yep.
And that's a whole rabbit hole into itself, hybrids and electric cars and how green they are. But the research I did today roundly says that in the end, a hybrid and electric car has a much smaller carbon footprint than a combustion engine.
Sure.
And I know about the batteries and I know where they get this stuff, and this is considering all the costs that go into making these cars and what happens to these cars over the years. There are a lot of smart people that put this all together, and it's still a better option than, a combustion gas engine.
Right.
But that's, I'm not here to say go out and get a hybrid or an electric car. That's up to you.
Well, that kind of raises one of the issues too, is like it can be expensive to be eco-friendly, which really sucks.
Yeah,
but
you can also save money though.
In the end, it's just the upfront costs are sometimes, greater, which is a problem for people who can't afford like a more expensive car. It's the same thing with like food, like the better your food, the more expensive it is, which sucks too.
Yeah, but you can use less energy in your home and pay less of a energy bill.
Yeah, no, there's plenty of things you can do. Like it doesn't cost anything to recycle,
Yeah, exactly. And all this stuff, like recycling, you think, well, I mean, I know that's good because there's no trash, but no trash means it's not going to that landfill, and that means it's not releasing bad gases into the atmosphere. So This all affects your carbon footprint. Recycling to how long you take a shower because you're using hot water, and that water has to be heated somehow.
Yep. And I mean, if this has become like an issue for you, then make it one of the things you vote on too. Like vote for people who care about this, and will make sure that regulations are put into place that fight climate change.
Yeah.
It's a big one.
There are politicians out there that care very much about this.
Yeah, I remember after we pulled out of the Paris Accord, like a few cities said, we're still doing this. We're going to stick to it regardless. So, you can do it. Your city can do it. Other people can do it. The rest of the world's doing it. Except for Nicaragua and Syria. If I remember correctly. You remember?
Yeah.
If you want to know more about global warming, just step outside. And since I said that, it's time for Listener Mail.
I'm going to call this So Smart I Don't Get It. But remember during the Buildering podcast, we read a listener mail about, we asked why you get sleepy when you read.
Yes.
Well, we had a chiropractor write in, and he says he has the answer. And I don't know if this is right or not, but it certainly sounds good to me.
Okay.
So he's a chiropractor, and he studied functional neurology in school. And he said the answer is that when you're reading, your eyes move laterally as they scan the page. This involves the lateral rectus muscle of the eye, which is innervated by the sixth cranial nerve, the abducens. So the abducens originates in the pons and the brainstem, and what happens is that as you activate this nerve through reading, you also activate the pontomedullary reticular formation, or PMRF. One job of the PMRF is to dampen the sympathetic response of the interomediolateral cell column in the spinal cord, which activates the sympathetic nervous system. In short, reading dampens the sympathetic response and relaxes you.
Nice.
I think that's the takeaway. I hope you find this interesting. Love your podcast. Use a lot of your knowledge you teach for Trivia Tuesday that my coworkers and I play at my clinic. And that is from Dr. Michael Hilton in Good old Washington, D.C.
Nice.
Or the district.
Thanks, Dr. Michael, the chiropractor from D.C.
That's right.
If you want to get in touch with us like Dr. Michael did, you can tweet to us at Josh Clark or SYSK Podcast. Both me and Chuck are on Facebook, and you can go to our official page at facebook.com/stuffyoushouldknow. You can send us an email to stuffpodcast@howstuffworks.com. And as always, join us at our home on the web, stuffyoushouldknow.com.
For more on this and thousands of other topics, visit howstuffworks.com.
The next time you end up with something on your shirt, don't turn to your usual detergent. Check out Tide Evo. Tide Evo represents over 10 years of innovation in product development. It's a revolutionary 100% concentrated waterless laundry tile made of compressed microfiber soap layers rather than liquid or powder. It's not pods and it's not sheets. It uses 6 layers of detergent fibers to deliver superior cold water cleaning without plastic packaging. It's mess-free, lightweight, and dissolves quickly. Try new Tide Evo. Real laundry magic.
Geico presents a 30-second podcast between your podcast. Today's story is shared by one of our listeners. It's called Betrayed by Bill. It was in that moment I caught who was staring back at me in betrayal, or more like what? My insurance bill. With trembling hands, I grabbed my phone and switched to Geico, saving about $900 in the process, and never to be betrayed again. Now that was bloody riveting.
It feels good when the story ends with savings. It feels good to Geico.
This is an iHeart podcast. Guaranteed human.